Hey everyone, my name is Lana Kalashnyk. I am a principal blockchain solutions architect at Amazon Web Services. Welcome to this ArcBlock DevCon 2020 session on Amazon Quantum Ledger Database. We wanted to uh, show you a little bit more and tell a little bit more about QLDB, which is a new backend integration that's available via ABT Node on ArcBlock dev platforms. So in this session, we will dive deeper into some of the basics behind what makes ledger databases different, how they're different from blockchain implementations, and go over a couple of use cases of how these technologies are being used. All right, so when we're looking at ledgers and audits, ledgers are not a new concept. For at least the last 5,000 years, record keeping has been a central theme for all civilizations around the world, and they have to deal with the same kinds of problems the way we do today. So traditional ledgers have been a book or other collection of financial accounts of a particular type. However, today we see ledger applications used not only in financial cases, but in any situation that requires any type of a system of a record. So some may ask, why does immutability and verifiability matter for a database? We have heard from many customers in various industries that this helps them to reduce risks. So that helps you ensure safeguarding of critical system of record application where data loss could be expensive. It also improves data tracking. So it helps you or any parties that have access to the system to quickly and accurately track data, entire lineage of the data, improve efficiency in tracking the source of issues. So for example, manufacturing defects, maintain supply network, data hygiene. It also provides for easier audit. So this way you can reuse downtime caused due to audit and compliance issues, having hundreds of productivity hours for your team, and also reduces implementation effort. So building in immutability and verifiability in a traditional way is time consuming, it's cumbersome, and turns out to be pretty expensive down the road. So there are some challenges with the current approaches to building ledgers with audit capacities. You may ask, what are some of the problems that our customers have been facing while implementing ledger or building system of record applications using traditional databases? Well, typically customers do this with relational database using custom audit trails and audit tables and so on. But at the end, it's pretty hard, it's complicated and expensive to build out and maintain systems. Also, relational databases are not inherently immutable. So this transaction history can be updated or overwritten. So there is no way to verify that something or someone who has full access to the system has not accidentally altered this data. Because of this and talking to thousands of our customers, we came up with the concept of ledgers with decentralized trust. So here we're talking about systems of here we're talking about systems of record for financial institutions with peer-to-peer payments, mortgage and lenders. So here we have some more complex process around syndicated loans. In retail, streamlining customer rewards and also inventory management and supply chains, typically international supply chains. So in this use case, blockchain networks with decentralized trust are a preferred where to go. But we also found a different class of use cases where it was actually better to implement a ledger for transactions with centralized trust. So when we're talking about centralized use cases, the ledger serves as the transparent, immutable, and verifiable record for a company's application and does not have the notion of a full-blown decentralized trust. And I will explain what that means later. Essentially, this means that this is the ledger itself, that it can be managed by one central authority. There are some mechanisms for which you can tie, let's say, digest or verification of nothing having been altered to wider blockchain networks, but we will dive into that a little bit later. So some of the use cases here are in healthcare, in DMV, for example, tracking a vehicle title history, in manufacturing, and a lot of other use cases. Because of this, we've launched Amazon QLDB. So Amazon QLDB is a fully managed ledger database that maintains a complete and verifiable history of ledgers over time. So in this diagram, we can see the what it looks like under the hood. So from the application perspective, a customer or a user would interact with QLDB just like they would with any other database, but it consists under the hood of two major components. The first one being the journal. So the journal is an append-only immutable journal that stores sequenced cryptographically verifiable entries for each change made. And this includes the entry itself, so the transaction, metadata, and the call being made in particle. And I will explain what particle is later on in the session. And the second large component is the current and historic histories. So here we can see the current state of the ledger, and we can pull up the indexed history for all of the changes for a transaction. Um, this is the first of its clients. This is the first of its kind solution because of the fact that QLDB is a journal first. So typically, when we're talking about concept of logs or journals, this is not a new concept. Typically, we address a ledger or we look at a journal or a log in the database senses when things are not going that great. So either we need to pull up and understand why some transaction failed, or if we're looking to replicate log or replicate transactions within the database. The problems with current ways of leveraging logs is that they weren't designed to be directly accessed. So it's usually an afterthought, figuring out how to access these logs. And also they're not readily cryptographically verifiable and immutable. So we've baked in those two concepts into the journal itself. So whether you insert data, you update or delete data, all of these transactions are added as blocks to the journal. And here we're seeing that we're seeing 3 blocks in the journal that are added here. So this is inserting data. So for example, we're adding a new record of ownership for a vehicle. So we're adding, let's say Tracy owns a Tesla A, then updating data. So this could be another block added here, changing ownership of the vehicle from Tracy to Bob. Here, what we're seeing is that both blocks are cryptographically linked to each other via hash chaining. And we're also able to add a delete call or a delete block. And this is a pretty powerful concept when we're talking about comparisons to blockchains, is that in the current and histories view, we can reflect that the item has been taken out of the our inventory, for example, but we do have this block that has information on this Tracy's vehicle that has been deleted, let's say, from our inventory, from our ledger. All of the transactions are immutable at the journal level. From current state, let's say we can update, remove transactions. So from that perspective, there's a lot of flexibility in having an immutable journal itself, but being able to run any operations on the current state and being able to pull up a full history of changes to your record. So in this example of managing a car that initially was owned by Tracy and then by Bob, is that we can pull up by VIN number, let's say, index history of all changes. QLDB also supports a SQL-like query language called Particle. It's extremely flexible, and we will touch on that in a couple of minutes here. And it's also a document database. So it does have ION data format, which is a superset of JSON. It's a strongly typed superset of JSON at that, which allows for numeric evaluation of decimals. And if you've parsed JSON before, it's kind of hard to do whenever you have to guess what exactly number type you're using, especially when we're talking about nulls. It is also serverless and scalable service that is fully managed on AWS. All right, so what is a journal? So the journal itself is this log of transactions that is sequenced. So each block within the journal contains the transaction data itself in ion format. It contains the hash, so this is your block hash, and other metadata such as timestamps. So all of the document revisions are stored in the journal and are linked to each other. So here we're seeing that each sequence is cryptographically linked to each following entry in the journal. All of the records are immutable. So here we're seeing that the journal is append only and sequenced. Actually, we didn't even build in any API to be able to remove or change any records from the journal itself. So it cannot be altered. And you can't produce a digest at any point in time. And digest, essentially, if you're familiar with concept of Merkle trees, is the tip of your Merkle tree. So you know that by comparing the hash, your SHA-256 hash, you can verify that nothing in the digest itself in the previous blocks has been altered. And if we wanted to touch very briefly on cryptographic hash and what we mean by this, so here we're talking about hash functions, which provide encryption by using an algorithm and no key. So they're called one-way hash functions because there's no way to reverse the encryption. No matter what the content of your document or transaction is, it is hashed into a fixed length hash value, which is often called a message digest or simply a hash. So by comparing hashes of data calculated at two different points in time, you can determine whether something has been changed meanwhile. So it's a pretty common approach to making sure that any changes to data within a database or any fields can be detectable. So how does cryptographic verification work in this case? So here we do have these blocks, or the concept of the blocks in the sense of QLDB that we've discussed, that contains the particle statement. So this is your SQL-like statement, let's say to insert, update, or delete a record. The record itself, so this is your ION document, which is a superset of JSON like we've discussed, and the metadata, and it contains a record hash. So at the end of, or at any point of time, let's say we've committed thousands of transactions and we want to save a copy of a digest, which is this final SHA-256 hash at this point in time, we can download this digest and save it locally on file and be able to come back, let's say, a year later and verify that none of the transactions have been altered. And that is possible because of one-way cryptographic functions via hashing. So I really wanted to touch briefly on Amazon Ion and Particle. These are really powerful new open source technologies that we've introduced as a part of Amazon QLDB launch. Amazon Ion is the way we store data in QLDB. So this is a document database. So it does allow for SQL-like querying capability, but it's good to keep in mind that actually it's a document DB under the hood for when you're designing your data models. Ion is a superset of JSON, which supports some additional data types. So for example, like I've mentioned earlier, instead of supporting a number, you can specify a decimal, let's say, and also you can specify number types for nulls even, which is really handy if you're looking to determine whether a null is a decimal null or a different number type. And like I've mentioned, it's a strongly typed data format. It is open source, so if you feel like you wanted to use or check out this format on your own, please feel free to download it. Here is the link to the GitHub repository with all the binaries you would need. And also ion documents can be complex and hierarchical, so which is really handy to manipulate large amounts of data. So this really helps us to create a more complex structures for processing. And the second open source technology that we've open sourced recently is Particle. So Particle is a SQL-like query language that natively supports complex structured data. So the coolest thing about Particle is that you can use your SQL queries or SQL-like queries, and you can query both structured and unstructured data with that, which is a really powerful concept. So here we're introducing a dot notation. So when we are looking to pull up an attribute, let's say of a vehicle that is a document stored within a table, we can say, let's say, vehicle.color. So from that perspective, we're cutting out some of the nasty queries that can be associated by building subqueries in traditional SQL. So that's something that our customers are finding as a quite powerful aspect of a Particle. It's also open source, so please feel free to pull it down. So it's used by multiple AWS services. So this is also an internal technology that we're bringing to market, just like QLDB and Ion. And it's worth noting that we've been using QLDB under the hood for many, many years. That's how we scale some of our most performant services. So this is a tried, true, and true technology. So something else I wanted to touch about is that all of the QLDB transactions are fully compliant with ACID. So this is your atomicity, consistency, isolation, and durability. And this is really important for important and regulated data loads. So here we're eliminating potential write skews, phantom reads, on-run repeatable reads. So essentially, these tend to happen whenever not all the transaction didn't fully commit to the ledger. So in this case, we can be fully comfortable knowing that either the entire transaction atomically succeeds or fails, in which case you can retry submitted the transactions later on. So a very powerful concept that is not typically available in other ledger technologies. So some of the other QLDB features, because this is an Amazon managed service, it is available within multiple, it automatically is provisioned in multiple copies per AZ, so it depends on which availability zone you're launching it. So you do have this automatic replication between 3 AZs, which is really important for HA and data availability. And it's pretty easy to use. So the team has been putting in a lot of work on building out new SDKs and drivers. So right now we have drivers in Java, Python, and Node, which are available on GitHub. We do have a purpose-built SDKs for QLDB, and it's pretty flexible and schemaless. So again, I would strongly encourage you to dive in and look a little bit deeper at Ion document format, and just really look at some of the flexibility that introduce into the equation. Something else that's very interesting is introduction of streaming QLDB out of the journal. So I think I'm not the only one who had to swap out databases under the hood. So as we were building these blockchain networks, sometimes where we store the ledger, the needs might change. So QLDB has been for me, for example, in my development work as golden copy. So essentially, as I persist transactions, I know that they're stored in a very flexible Ion format. I can have a full historical data of all of the permutations on the transactions that have been committed to the ledger. And from that point on, I can stream out all of these transactions and replay them via Kinesis-powered data streams into, let's say, object stores such as S3, could be time stream database or anything else. And this is a powerful complex because if I decide to use, let's say, a different access pattern to where I choose to, let's say, perform analytics or really focus on time streams or other machine learning, I can easily switch out where I'm streaming out data out of QLDB. So you can emit these transactions and data directly to Amazon Kinesis data streams and go on with your business. So this is why we've built um, Amazon QLDB. If you have any questions on how that's different from blockchain solutions, please let me know. So the main takeaway here is QLDB takes care of cryptographic verification in a very lightweight, flexible way, which allows blockchain builders to focus on figuring out the right consensus mechanism in smart contracts engine that could be layered on top, which is exactly what ABT provides with using QLDB as the ledger, and then the rest of the platform sits on top of it. So I believe we do have a demo later on in the day, so very excited to check that one out. I will touch really briefly on some of the customer use cases. So we are seeing quite a bit of adoption with ledger databases. So the use case range from track and trace to inventory management to asset provenance. So here we're really looking into how those are used and digital wallets. So one of the use cases here is our work with BMW, which you can pull up as a case study, activity trackers, data marketplaces. So a lot of tons of data that could be stored in the ledger-like append-only manner, and then later on be manipulated, let's say, to derive any insights that you might need. Like I've mentioned a second ago, one of the use cases that's pretty exciting is a BMW. So here we've built a wallet that essentially is representation of a vehicle's history here. So for automotive data and so on. And another example that's quite easy to get through, if you get a chance and you wanted to get into QLDB console, there's actually a built-in simple data set that allows you to really step through creating a transaction, appending it and deleting it. And the example is for the driver and vehicle licensing agency. So it's an actual use case that we've implemented for a customer in the UK, which is pretty cool. And also for Trust Fabric. So here, when we're going back to where we started in this presentation on looking deeper at ledgers of system of record and understanding how accounting is done. So Sage is redefining this trust fabric between multiple entities. So I strongly encourage you to look into some of the use cases of how some enterprise customers are using ledger and cryptographic verification technology. Thank you so much for your time today. Like I said, my name is Lana Kalashnyk. I'm on Twitter. If you wanted to get a hold of us personally, please email this alias, and one of us will make sure to get back with you. And I hope you enjoyed the rest of your session and have a great weekend.
Hi everyone, this is Jonathan from ArcBlock, and in this section I'm going to show you how to use AWS QLDB in ABT Node. As you can see in the previous section, AWS QLDB is a cloud-based ledger database, which would be very useful in many use cases. And so in this case, we at ArcBlock, we decided to make adapter layer that allow our users to plug into QLDB pretty easily especially when you have experience working with ArcBlock's blockchain before. And the basic steps for doing this integration is first, you need to create an AWS account and create a QLDB ledger database. And also you need to set up a IAM account for the QLDB access for the node, and then you just run your node and install a blocklet called the QLDB manager, and use the AWS IAM credentials to basically assign them to the blocklet so that it can access the ledger database on your behalf. And then later on, if you want to, you and your code, if you want to visit the QLDB database, you basically just need to send request, a GraphQL request, the same way you did for ArcBlock blockchain backend. So now I'm going to walk you through using a demo. So now you can see I'm here in the AWS console, and here's the QLDB page. And here in the ledgers tab, I've already have some ledger database set up, and the one we're going to use is the OCAP QLDB demo database. And now let's go back to our newly set up ABT node. And let's go to Marketplace and try to get this QLDB manager installed. All right. So now we have QLDB manager installed, and if we open it, it will like alert us saying the configuration in red should be provided to start the blocklet. So we are missing two configurations. One is the access key ID. The other is secret access key. So these could be found in the AWS IAM management console. So I have this already set up, this demo account set up here, and I'll just copy and paste and assign them to the QLDB database, QLDB manager. And then the ledger is OCAP QLDB demo. If you're using a different name, you can modify it, and also the region we're using US West 2. So now we have all the configuration set. Let's go ahead and try to start it. All right, so now you can see here we have a public interface. So this interface is actually a GraphQL backend endpoint. So if you're familiar with working with ArcBlock's blockchain, you know that the ArcBlock blockchain also provides a GraphQL interface. So you as a developer can send GraphQL requests to the chain to get the status of accounts and transactions and things like that. And we are trying to provide the same experience for developer when working with QLDB. So this is actually what the QLDB manager does. So it acts as a adapter layer. So you can basically use the same method you use to working with ArcBlock blockchain to just switch the GraphQL endpoint and pointing towards the QLDB manager, and then you'll be able to write data into the QLDB database or read data out from it. So let's do a quick demo and see how it works here. And we have another blocklet called blockchain boarding gate. So this is a simple blocklet that allows you to specify a blockchain backend with the GraphQL endpoint, and then you can scan the QR code to create an account on that backend, and also maybe try to get some token from the backend. So let's go ahead and try this Boarding Gate Blocklet. So let's use this this backend as the blockchain we want to connect to. And now we can use our wallet to scan the QR code and create an account. So, and then we can scan the QR code here to try to get some token. And later on, we will be able, or we can go to the ledger database to check if this account and the token transactions are actually recorded in the backend. So, and now let's go back to the GraphQL to the marketplace. So we have a blockchain explorer blocklet. So in the previous section, we introduced this product. So this is actually a universal explorer that you will be able to just specify a backend, and then the explorer will be able to track the accounts and transactions and stuff from that blockchain. So let's go ahead and see this one here. Let's try to add the backend here. And now let's switch to this blockchain backend. And as you can see, we just declared an account, and we also just did a checking. So if we look at this account, we can see that this address has 1,000 demo token. This is because we just scanned the second QR code to do the checking. And so this is how it works here. And let's copy this address and go to this query editor and see if we can check if the account is actually created in QLDB. And as you can see here, it's actually created. All right, so what we did is just a simple demo to showcase how to integrate with AWS QLDB in ABT Node. And I think this is very powerful for people who want to use a cloud-based ledger database to tackle some enterprise use cases. And you guys can try it out with the latest ABT Node and the blocklet. And feel free to reach out if you have any questions or problems hitting when you're trying to set up this integration.